Me?
Can't see you. Can't see you. Do you have like one of those sliders on your camera?
No, there's probably some setting that says which camera do you want to use.
Okay.
But I'm not super handy with the Zoom. Oh, there we go. Microsoft LifeCam camera. Let's see if this works. There we go. There. The background light.
Okay, I think we can start now then. Hopefully more people will trickle. Welcome to the International School Titan Robotics Club Computer Science webinar. Titan Robotics Club is hosting a series of webinars surrounding a variety of different careers. Our webinars are posted on YouTube, and this one will be on our YouTube as well, so make sure to check that out. And then if you're interested in getting involved with robotics, join a FIRST robotics team in your community. International School has several different robotics teams for both middle and high schoolers, so make sure to join in the fall. We'll be starting our webinar shortly, and if you have any questions, feel free to put them in the chat since we'll have a Q&A session at the end. And then our guest speaker today is Marc Shepard. Okay, Pat.
Hi, everybody. Yeah, my name is Marc Shepard. I'm the IS computer science teacher. I was asked to talk about a little bit about why career in computer science, maybe talk a little bit about my background, tell a few stories, and then we'll do some Q&A. So a little bit about me. I'm a second-year teacher, so just getting started. Way back in the day, I got my doctorate in math from UC Berkeley in '91, and that's where I met my wife, Stella Shepard. So she actually recruited me to international school. She worked here before I did. We got married in Berkeley. Technically, it was the First Unitarian Church of Berkeley, but it was really in Kensington. But the joke is they don't call it the First Unitarian Church of Kensington because it would have had an unfortunate acronym. And after I graduated, I went and became a software engineer for about 30 years. I worked for the first 7 years at a company called Wind River Systems that does embedded systems programming, which is not unlike robotics, where the computer that the device runs on isn't a traditional computer. And we'll talk more about that later. And then I spent the last 23 years working at Microsoft. That's what I came up to the Northwest for. I retired in 21, and then Stella talked me into coming to international school and teaching instead of taking some time off. So the motivation for teaching was opportunity to give back to the community. The software tech industry has been good for us, and so now feels like a good time to give back. On a personal note, I got a couple of daughters, age 22 and 25. We all have birthdays right around the same time. Actually, the youngest one and I have a birthday coming up in a couple of weeks, same day, and the other one is 5 days later. I grew up in New York, lived there for 20 years, moved to the Bay Area for graduate school for Berkeley, and that's where I met Stella. We lived there for 13 years, and then we've been up here in Bellevue for the last 24. I like doing outdoorsy stuff. Skiing and snowboarding are great, and paragliding, hiking, biking, anything that's outdoors. Love playing with the games like Oculus Quest VR is amazing. I love watching the Seahawks. I'm a lifelong Seahawks fan. Even though I'm not from Seattle, I watched them in '79 beat the Atlanta Falcons on Monday Night Football using all these gadget plays. And Efren Herrera, the kicker, was the star. And I sent them a letter going, "You guys are cool," because I was a little kid. And they sent me back a bunch of stickers. And then I became a lifelong fan after that. So it was destiny that I came here. And more about that later. But why computer science? Why should you go into computer science? Well, one of the benefits is there are a lot more jobs than there are qualified people, and the jobs pay really well. So after working in computer science for a while, you can really work anywhere you want. You don't have to, it's not like, oh, I'm going to be a nuclear physicist, so I better work in Los Alamos or Lawrence Livermore. It's like, no, you can work anywhere, and it pays well. Like, so after a few years of working in the industry, you can retire and live in Tahiti or teach computer science at international school. Students like computer science. It's actually considered a fun class. Survey after survey says one of the top classes, and there's a lot of correlation between people who take computer science and success at other disciplines. There's a lot of career opportunities in computer science. Within the scope of software engineering, you can work on web, you can work on data, you can work on architecture, but there's a whole bunch of disciplines aside from programming. People go into computer science, work at a big company, and there's a sales team if you're just a people person. There's marketing. Marketing figures out strategy and how to position new products. User experience design engineer. So those are the people that actually figure out what should the user interface be for some product that you're building to make it really good for the end user. Apple is unique in that their user experience design engineers are the center for their product design. So they come up with it first, and then the rest of the engineering department figures out, how to make it happen. Most other companies don't do it quite to that extreme, where sometimes UX design comes after the main product is built. But it's a great discipline also for people who don't want to strictly program. A program manager, I did that my last bunch of years at Microsoft. I started off as a developer, but I switched to program managers, and that's where you're figuring out what you should build next and communicating it in a detailed level to your developers. Product manager, they sort of are in charge of the execution, make sure people stay on track, and do we have enough resources to build this out in time. But even within development engineer, there's a whole bunch of different career tracks as you sort of move on. People start off as junior programmers where they, somebody has to tell them what to do, and, some close mentorship for how to do it and how to get unblocked. Then they eventually become senior engineers where they, need to know roughly what to do, but they can figure it out largely on their own. Eventually, people move up and become architects, where you sort of figure out how the whole system should be built, and you collaborate with people to make sure everybody's building the right pieces. Or people sometimes take the management track, where they are more focused on sort of people skills and growing the skills of their people. So that's it for the disciplines. If you're gonna, but just learning a little bit about development is sort of a prereq really for all of it, because you should know a little bit. And so there are a lot of programming languages, and people often say, what should I start with? What should I learn first? And it turns out there is no single programming language. There's a ton of programming languages. They're all good in their own way. Java and Python are two of the most popular ones, as well as JavaScript. I always tell people it doesn't really matter what you start with, because once you learn one, the others are easy. But if I had to pick one, I would probably pick Python first. Python is the one that everybody uses these days for data science, and data science is a very hot topic. It's also great for building web microservices, and it's really the easiest first language to learn. It's syntactically simple, and it's just a pleasure to learn. Java, definitely a lot more complicated, but it's better for very large and collaborative code bases, because it's a compiled language. So the compiler actually finds a lot of problems across the code base ahead of time before you ever run it. So it's really sort of better suited for those kinds of projects. Definitely a harder language to learn syntactically. JavaScript it's got nothing to do with Java. I don't know why they called it JavaScript. I think it was just branding, but it's a scripting language that, like Python, but it's mostly for web pages. So all the interactivity you get in web pages, it's all built in JavaScript. C and C++, this is where you're writing really lower level programming. That's where I started. That was my first. And if you're writing something that's very, very low level, needs to be high performance, the highest of performance. So if you're building an operating system, if you're building compilers, if you're building games, those are typically written in C or C++, or if you're building a database. C#, that was Microsoft's answer to Java. It's actually a better version of Java. It solves a lot of the problems that Java had in terms of not having operator overloading and other things like that. It's actually much more pleasurable to code in my opinion. Yeah, so anyway, lots of languages, doesn't matter what you start with, they're all great. I wanted to tell a few stories about my my path. So I was an undergraduate in Stony Brook, out in Long Island where I grew up. And the good is I did great at math. I finished my undergraduate courses my sophomore year. I was something like 96th percentile on the GREs in math. So math was good and easy. But the bad was, I think I was like 49th percentile in English, and I failed 7 classes. So I always joke that I'm an expert in physics because I took physics 1, I failed it. I took it again, I got an A. I took physics 2, I failed it. I took it again, I got a B. I took physics 3, I failed it. I took it again and failed it again. So that's 6 semesters of physics. So if you ever have questions about physics, you know who to talk to. But I finally figured out the problem was all the classes that started before 10 a.m. I failed. So I stopped taking classes before 10 a.m. and that kind of turned things around for me. And then I was able to get into Berkeley. I love math. So I actually, Berkeley was just a pleasure to go for graduate school there. Very interesting place for me, going to the West Coast and all the mountains. But near the end of when I was getting my last year or so, I started looking about what would happen next. And it turns out with a math career, you have to get these postdocs, they're called, and they pay nothing. And then you have to travel and live in some place you don't really want to live. And then you try to eventually get to tenure. So it's sort of a very low paying, not very nice track. Like a lot of people have heard like, oh, my friend is an adjunct professor. Turns out adjunct professors is how like colleges staff half their teaching. And they're just people that they pay, almost minimum wage to do hourly work. So, the tenured professors, they have a reasonably good deal, but it's a hard path to get there. So what I wound up doing is I took a couple of CS classes at the end. I took, my first one was called C Programming and Data Structures. It was a 200 level class. It was maybe similar to AP Comp Sci Java, maybe a little bit more advanced, but similar. And I took a course in OS concepts, and I loved them both. And that was back before we had PCs. So I was doing all my work in the labs in Berkeley, and I would sometimes borrow Stella's car, and then I would get so lost in the programming because I really enjoyed it. I'd come home at like 3, 4 in the morning, and then Stella would say, "Did you remember the car?" And I'd be like, "Oh, that sinking feeling where because at Berkeley it's like towing zone in the morning, so it's like I had to walk back then in the middle of the night, get her car, drive it back." And then she got to the point where she was putting stickers on the door that said, "Did you remember the car?" And it happened to me several times. But the main point was I love coding. I would just get lost in it and realize that was probably something I wanted to go into because easy to get a job, pays great, and I really enjoyed it. So my first job out of after finishing Berkeley, right after I graduated from Berkeley, Stella and I got married. And then I took a job at this company called Wind River Systems, which is also in the Bay Area. It's in Alameda. It's an embedded operating system, and it has the operating system written in C and assembler. So I got to work on that. We used to talk about, and you probably would appreciate this from robotics folks, is we used to have this internal motto. Obviously, it wasn't the company's logo, called "It's the tool, stupid." So the idea there was to remind people that it's not the operating system that people pay for, it's the development tools that make it easy for somebody to write code on their PC and then push it to run on the embedded system and then debug it and test it and make that turnaround cycle very quick and fun and efficient. And so that's what we worked on. I think one of my favorite projects, I wrote a debug agent that ran on the device, and it could talk to the GNU debugger from the desktop. And it would take remote commands, and you could put it in task mode, in which case somebody hits a breakpoint and just that thread would stop. Or you could put it in system mode and the entire operating system would stop, and you could step through interrupt service routines. So it was very low level C and assembly level programming, but it was a blast. And the people there were fun. Like we used to have, like Wednesday was beer and hockey night. And then this one guy who sort of organized it all, he quit the company to try to start a brewery in Hawaii, which wound up not being successful. But one day, a whole bunch of us went and visited him on the Big Island where he was living. And we went up to Mauna Kea to the top where they have all the observatories. And so we just, walking around, and we get to the first observatory. I rang the doorbell. They had a doorbell out there. So it's like, okay, you got to push it, right? And the guy goes, who is it? And I was like, it's me, comrade. The password is mongoose. And he's like, who is it? And I'm like, no, we're just a bunch of tourists. We were hoping you'd show us around. And all my friends are like cringing, going like, dude, you're embarrassing us. And then the guy goes, I'll be down in 2 minutes. And so he opened up the door. He showed us around the observatory. It turns out they were using our operating system, Wind River's operating system, VxWorks, to control all the telescopes. Apparently, most of them were use VxWorks. So that wound up being really a blast and interesting. Although they were using an older version of the operating system than we worked on, but still, it was very cool. Another story from the Wind River days is it turns out the Wind River operating system was used by Jet Propulsion's lab for building the parts of the controller for the Mars landers. And I remember they asked Wind River before they launched whether we would want to be part of their press release. And everybody said no, because they said, this is how it's going to work. Instead of there being a nice retro rocket that's going to land the modules and the rovers down gently, instead, it's going to just let them go from a parachute. And then they're going to have these balloons outside them, and they're going to bounce, and then open up. And we thought, that's never going to work. So everybody was like, no, we don't want to be part of the press release. But then it did work. And so then we were like, oh yes, that was us. We were part of it. So anyway, that was the embedded systems world. I'm supposed to be advancing these PowerPoint slides. So that's so after that was Microsoft. As I mentioned, I was been a Seahawks fan since '79, so it was destiny that I came here. But my first trip up here wasn't until '98, where my stepbrother organized a trip to climb Mount Rainier. And that wound up being just a blast of a trip. Long stories for another time. But I will say a month later, I got a cold call from a recruiter, because it turns out Microsoft was trying to hire people in the embedded system for Windows Embedded. And I guess they got my name because I worked for an embedded systems company. So they said, hey, we'll take you and Stella and your daughter, we'll put you up in a hotel, like a free weekend in Seattle, if you'll interview with Microsoft. And I really had no intention to move up here, but then I thought, well, it was kind of a cool place. I really enjoyed the trip for Rainier. So we came up for the weekend, and then they booked a real estate tour, and things were so much cheaper here than in the Bay Area. And it's so beautiful here. So we wound up taking the job. Started in January of '99. And I just can't say enough good things about Microsoft. I mean, the diversity of things that you can work on is just amazing. Doesn't matter whether you want like databases or advertising or, machine learning or whatever. There's opportunities there. And of course, I love this area too, because it's got that also fantastic blend of like city life and outdoorsy stuff. 20 minutes to downtown Seattle, 40 minutes to Snoqualmie Pass. So cool. But I will say this about Microsoft: the culture has changed quite a bit since I got here. When I first got here in '99, it was a monopoly. Like Microsoft, if you had a computer, it was almost certainly Microsoft PC. Because back then there were no smartphones, so no iPhones, no anything like that. And Apple and Linux had like 3% market share. Apple was about to go out of business at that point. So it was just Microsoft, and we were under intense scrutiny from the Department of Justice for being a monopoly, because we would, squelch strategic threats like Netscape and Java. And so we intentionally kept Apple alive back then. We gave them money. We ported Office to the Mac. a whole bunch of things, to relieve the DOJ pressure. All that's changed radically now, right? Now phones are king, PCs are sort of an afterthought. And even within the PC sector, Apple is doing great. Although Microsoft's still doing great, just, it's not the only option now. Also back then, security was an afterthought. When I joined, the internet was very nascent. So it was a curiosity. And so without the internet, there's no good vector for spreading viruses. And so nobody really thought about security. So there were tons of security gaps in Windows. So people would write their C code where you could have buffer overruns that was all over the place. So many viruses. And so it happened not just to other companies that had Windows, but it was happening internally at Microsoft. Sometimes the viruses would spread around. We'd have to reset our PCs. And then as soon as you boot up, it contaminates. So then suddenly there was a huge company initiative to stop it. And that was like a multifaceted thing across, like all hands on deck. I worked on Microsoft Update, which was a big initiative at the time. Before that, there was Windows Update, where from your PC, you could go to Windows Update and you could look for updates. They weren't pushed at you. And so the big change was we would push updates at you, and it wouldn't just be for Windows, it would be for other Microsoft products like Office. And that was a really fun project, especially the scale. It turns out we had about 1 billion, still do, about 1 billion consumer PCs that are out there. And so our big worry as we were designing it was there's a bunch of trade-offs where how do you push updates in a timely fashion? Because a lot of the security threats already had fixes. We just weren't pushing them out. So this is why it came down to security. If you can push out the security fixes in a timely way, you would way reduce the amount of viruses. So that was one of the ways we went after security. But pushing out updates to 1 billion computers, balancing how you do that in a timely manner, but still not disrupting the end users, and not bringing down the internet. We actually figured out the whole internet would crash if we pushed it out too quick. So that was super challenging to get all that right. And we also built out this parallel infrastructure called WSUS, which is sort of Windows Update in a box for corporations. So a company or an educational site like BSD would have a WSUS server. Maybe WSUS would be embedded in another product like System Center, and it would sit in your corporate environment. And then you could pull the updates from Windows Update into your WSUS server and then sort of control the distribution of them. So that also affected, I think, another 200, 300 million people, devices that were corporate devices. So it was like 1.3 billion devices altogether between the two technologies. And so just working at stuff at that scale was pretty fun, pretty satisfying. Now, of course, those days when security was an afterthought have changed. Now Microsoft, it's everything that engineering does is focused on security. So that's that. Another thing that's changed is when I first started, being abrasive was common and respected, and it came from the top down. Like people were afraid to go to Bill G or Steve Ballmer reviews because they would just yell, you didn't show up, you didn't know everything. Or they didn't like how you thought about it, they'd call you an idiot. And that kind of culture trickled down. That's no longer the case. Now under Satya, it's sort of a kinder and gentler environment. I had a great manager once named Catherine Holdsworth who asked me, what do you want to work on? And I said, well, I'd like to work on being less abrasive. And so she signed me up for this class called Dale Carnegie. And man, I love that class. I found it transformational. A lot of people took the class because they were nervous about public speaking and they wanted to help with the public speaking. For me, it was more just how do I become less abrasive, and it was fun. And they teach me some technique like, oh, okay, find something to appreciate in the other person and be sincere. And then I'd go home and I'd practice on Stella. I'd be like, Stella, did I ever tell you how much I appreciate when you do blah, blah, blah? No, and then she would look at me and go, I know you're doing this for the Dale Carnegie class, but keep doing it. It's working. So anyway, we all learned to be less abrasive. There were another thing has changed. There were crazy good perks when I started. I mean, they still are. Microsoft benefits are still very good. But when I got here, they had the Prime card. You could go to the aquarium, you could go to the Seattle Center, you could go to the IMAX movies, all free for you and your friends and your family. And then after a couple of years, they made it just for you and your family. And now it's like, you get $20 off or something. So it's changed a lot. They used to have the company meetings would be in Safeco Field, and they'd have huge fun productions that were just hilarious. And they would have a company picnic every year at the base of Mount Si that had, food and beverages and monster trucks and all sorts of stuff. And then of course, medical insurance, there was no copay. People would see your Primera card. They'd be like, come on in. So all those things have been scoped down, and Microsoft still has really good benefits relative to the industry, but it's no longer sort of over the top crazy like it was. But overall, Microsoft, 2 thumbs up. I finished Microsoft and I was planning on retiring a year and a half ago, and I was going to take at least a year off, maybe more, maybe a lot more, and then figure out a way to give back to the community. And then Stella said, hey, the computer science teacher here left. Why don't you take the job at IS and then you can work with me? And so I did, and I thought, okay, great, chance to do it. So I never got my gap year. I'll say the first year teaching was crazy hard. Just learning the tech, even though I was a program manager my last bunch of years at Microsoft, relearning how to do the programming was pretty easy. But learning how to teach and how to grade, way harder. And that's something I'm still find humbling and I'm still learning. But I do have to say the international school kids are just amazing, so incredibly smart and talented that it's definitely a pleasure to be able to work with such talented kids. And I do want to say, going forward, I am a data science hobbyist. It's just a fun topic because it blends my first love, which was math, with computer science, which I've been doing for the last 25 years. And it's in the press everywhere, of course. If you hear about ChatGPT and other things like that, which is, the latest disruptor, it's being used for more and more things. And I would say, if anybody out there is interested in computer science, you want to get your feet wet and learn a little bit about data science in particular, Kaggle Learn, great place to start, great resource. You'll learn some Python and you'll learn how to use some of the data science stuff, maybe even go into competitions. So anyway, I guess I've been rambling for a while, so I will stop there and take questions.
Okay, we have a couple questions. Let me open the page. Okay. Okay, the first question is, what skills do you think are most valuable in the workplace apart from good problem solving and coding ability?
Definitely collaboration and people skills. Like in every software project I've ever worked on, or anyone that's of any significance, it's going to take a team to build it. And so you have to be able to get on the same page. You have to be able to brainstorm together. You have to be able to collaborate together. And when deadlines are near and tensions are high, you got to be able to be nice to each other and be supportive. So definitely collaboration.
Okay, and then the next one is, what did you learn from working at Microsoft, and what skills did you take away from working there?
Oh man, I mean, I worked there for so long that I like 23 years, so I learned a lot of things. I would say I mentioned the Dale Carnegie class. Those are skills I'm still working on. Not they don't come naturally to me, but that was it. Technology wise, I only knew C going into Microsoft and a little C++. So I got to learn Java. I got to learn C#. I got to learn SQL. And then as a program manager, I did some data analysis and data analytics. And then learned as a program manager sort of how to, I guess we call it herd the cats, how to get as a program manager, it's your job to basically sell, like, here's the thing that we should build next, here's how we should do it, and sort of, communicate, I would say.
Okay.
All right, I'll be asking the next few questions. So the first one is, what is your preferred language to code in? And what are the differences between the different languages?
I like them all, but I think Python is super fun. I like it. It's syntactically cleaner than Java. Java's just filled with inconsistencies. Like an array has a length attribute, and strings have a length function, and array list has a size function, just full of inconsistencies. Python's just nice and clean and simple. So I like it for smaller programs. For larger programming environments, I guess C# is great. C was kind of a little bit of a pain just because it's so low level. You have to do the memory management and make sure you allocate and free the memory in just the right spots. So it's a little more complicated to get right.
Yeah, I really like how Python's easy to read too.
Mhm.
All right, next question. Any suggestions for middle schoolers on computer science learning?
Middle schoolers. Well, I think probably the best language to start with, if you've never done any programming before, is Scratch. It's a sort of a graphical drag and drop. And I think I've shown you and a bunch of the other things, some of the fun projects I did with that. I wrote that hungry atom for the chemistry teacher. And it's just a fun language to mess around with, and you can put some pretty interesting things together very quickly. But once you move past that, I would say Python next. It's probably the next best one.
All right, cool. And the next question, how have your educational and professional experience helped you shape your computer science classes?
Yeah, it's a good question. Well, I mean, having worked in the industry for a long time, it's very easy for me to then sort of bring in sort of anecdotes like, here's why this thing is important, and sort of provide a bigger picture. One of the things I do, as you know, is the weekly distraction, where we bring in some industry topic each week, for a few minutes, just to sort of talk about the bigger picture outside of the class. I think, having been a teaching assistant for 6 years when I was a graduate student, sort of helped me a little bit with the teaching, but I would say nothing really prepares you for teaching. So really a lot of it is, man, teaching is hard. I have to say I have a new respect for it now that I've been doing it.
Thank
All
you,
right.
Mark. Our next question is, there are a lot of computer programming courses such as Python, C++, Java, etc. When should kids start learning it, and what language should kids start with?
Like I said, if really young kids, start with Scratch, the drag and drop one. Anybody else, start with Python. Those are the two easiest ones to get started with. So I 100% recommend those two.
Thank you. And the next question is, if kids don't like math, can they still get into the field of computer science? In other words, how important is math to computer science, and how are the two fields connected?
Yeah, you can do an awful lot of computer science without any math at all. I think if you want to get into data science, you need math. There's an old joke, or sort of unofficial definition of a data scientist, is it's somebody that knows math better than the programmers and programming better than the mathematicians. So if you want to get into data science, you really need both of them. If you want to go into any other field in computer science, you don't really need math. For example, UX design, there's no math in that, right? That's just empathy for the end user and some creativity.
Thank you. And our next question is, what types of STEM position require a PhD?
I'm not sure that anything requires a PhD. I mean, I really look at degrees as things that help you get your foot in the door for some job and some career track. Once you've got your foot in the door for the job and the career track, it's really up to you. This is if you're going into industry. Of course, if you want to go in and become a professor, you need a PhD. But if you're going into industry, you know, the degree matters much, much less than the experience.
Okay. Oh, okay, thank you. The next question is, do you think artificial intelligence will replace programmers in the future? They saw some code that ChatGPT created.
Do I think it'll do what in the future? I'm sorry, I didn't hear the question.
Oh, sorry. The question was, do you think AI will replace programmers in the future? I saw some code that ChatGPT created.
It's interesting. My stepbrother, who works at Amazon as a IT architect, he was telling me that he thought that it was going to replace programmers or do all the things for programmers. And so then I asked ChatGPT, because my experience, I only played with it very briefly. My experience was ChatGPT is really good at generating short bits of code or skeleton bits of code. So I could say, write me a binary search in Python, or write me a quick sort in Java, and it'll spit out perfect code for that. But if you ask it, like, write me a hungry snake game, it won't really do that well. It'll put some outlines in there. So I think it's a long, and there's it's mathematically provable that it's like an intractable problem to write, correct code, bug-free code, or prove that a code is bug-free. And so, as the program size gets larger, it gets exponentially harder to do these things. So I think it's probably going to be that AI stays good at generating small bits of code, but Microsoft's investing. Heard Microsoft just put another $10 billion into ChatGPT and OpenAI, and apparently they're hiring like 1,000 engineers to help train it on programming. So they're training it with on how to write code. So I know that the code writing ability of it is actually pretty good right now, especially for small chunks. And it's going to get better because they're investing heavily. But it'll probably be a long time, if ever, before it can replace people. But it become a valuable tool for programmers, right? Because if you can get it to write chunks of code for you, then you've got those and you don't have to write them by hand.
Thank you. Next question. What's something that students can do to improve their coding at home?
To improve their coding at home? Do more of it. And look at other people's code. One of the ways I learned when I got to Microsoft was, I started the project for working on Microsoft Update. I wrote the client web service, and I could look at other people's code and how they wrote their stuff. And, now code is out there ubiquitously, right? You can go to GitHub and you can go Replit, and you can go look at what other people have created, and you can see some of the techniques they've used and learn from that. Also taking some online courses, and just practice.
Next question. What's a good study plan to go by throughout high school for computer science?
A study plan for computer science? Well, I only can speak for international school. It's the only one I know. I'm a new teacher, right? So my experience is somewhat limited here. For international school, I recommend people start with a Python class and then take either the AP Comp Sci or AP Comp Sci Principles as their second class. People who already feel like they've got a good programming background and solid footing, then maybe start with AP Comp Sci Principles and then go to AP Comp Sci. AP Comp Sci Principles is sort of a class where there's a lot of collaboration and you do group programming. It's not as in-depth on the programming side. They start with Scratch, they do a little Python, but it's more about concepts. So they learn a lot of concepts, and they do a little bit of programming, and it's group programming. So it's a fun class. The AP Comp Sci class, the Java class, very deep class with a lot of corner cases. And do you have all the corner cases memorized for Java? So that one's probably the hardest class. Some people who feel really, really strong at programming, they could start with the Java class, the AP Comp Sci, and then they could take this other class we have called Special Topics, their second year, which lets them, do independent study. So those are the paths we have in our school. We only have 2 grades that can take it, so you only have 2 years. But again, I would start with Python, then consider principles, then consider Java. I think that's a good path.
Okay, thank you. Does anyone have any more questions? Okay, thanks for coming to the computer science webinar, and thanks Marc Shepard for being our guest today. We'll be hosting more webinars in the future, so make sure to be on the lookout for more opportunities to learn. Thank you.
Bye.
Thanks, Mark.
Thank
Thank you, Mark.
you.
Thank you.